Had a couple of people ask for different strategies for adding and taking away.
I think if you were like me growing up, you were only ever shown one way to add double digits, and that was vertically, where we have 9 add 5 is 14, you carry your number over to find your answer.
That whole idea of carrying a number over can be quite complicated because it's ones and tens and hundreds, so there's a few different strategies that you could try with your kids.
First one gives loads of flexibility, it's called a number line. What I'd do is I'd put one number at the end, 49, and then I would add 35 any way that makes sense to me. So I could add 1 to get to 50, add 30 to get to 80, and then add the remaining 4 to get 84. I can check that I'm definitely right by adding up the numbers I've added. So 30 add 4 add 1 is 35. Another method is compensation. This is when I can add to one of the numbers to make it easier to calculate. So for example, if I add 1 to 49, I get 35 add 50, which is 85, and then I need to take away that 1 because I added it on, so I get 84. Partitioning is a really good way to understand if kids have a real grasp of the numbers. What we're going to do is split these into tens and ones. So we've got 30 and 5 and 40 and 9. Then I add the tens together to get 70, add the ones to get 14, add the 2 together, 84 again.
Now there is a final strategy I would use called expanded vertical, and you might really like this one.
Now this has mean that I'm actually having to think what the numbers represent. So I've got 9 add 5 is 14. Now I'm thinking this is 40 add 30, which is 70. Add the 2 together, 84. I find expanded vertical to be really useful for larger sums like this one. See, traditionally we have to cross numbers out and to carry things over, and that can get really messy and confusing. Whereas with expanded vertical, 8 take away 6 is 2, 40 take away 50 is minus 10, 100 take away 900 is minus 800, and 3000 take away 1000 is, oh, it's not 1000, it's 2000. And then I just complete the sum to find my answer.